Alright, I'm going to go ahead and go through the answers for the Systems of Equations Unit Practice Test to help you guys study for your test tomorrow. So for 1 through 5, they want you to solve them using the appropriate methods, so either substitution, elimination, or graphing. For this first one, I noticed that they're both in the y equals mx plus b form, so that's an easy one to graph. It's going to be hard to graph this one though, just because of the y-intercepts. They're a little hard to graph on this one, so while you could have graphed this one and you'll notice that they're parallel lines, I'm actually going to use substitution for this one just since the y-intercepts are so large. So I'm going to do 2x plus 32 equals 2x plus 8, and I will subtract my 2x from both sides, and when I do that I get 32 equals 8. 32 will never equal 8, so this problem is a no solution problem. If you graphed it, you would have ended up with two parallel lines. Whenever you have two parallel lines, is also no solution. Those lines are never going to intersect. Okay. For number 2, I noticed that these coefficients are both 2. Since they're the same, I know that it's going to be easy for me to eliminate one of them if I just change the sign to negative. So I'm going to multiply my bottom one by -1. So my new system will be 2x plus 7y equals 5, and negative 2x minus 3y equals a -9. Elimination method is also called the addition method, so you're technically adding these two equations together. When I do that, I get 4y equals -4. Solve for y, and I get y equals -1. Then I'm going to take my -1, plug it back into my original equation, so 2x plus 3 times -1 equals 9. 2x minus 3 equals 9. And I'm going to solve for x here, and I get x equals 6. So my solution was 6, -1. For number 3, I'm actually going to use substitution for this one. You could change this to y equals mx plus b form by adding this 3 to both sides and graphing it here. But just to save from graphing on this one, I'm going to substitute. So I'm going to substitute 2x plus 3 in for y on my second equation. And when I do that, I get 2x equals 2x. 2x will always equal 2x, so this is an infinite solutions problem. They are the same line. Alright, for number 4, I'm going to change one of these so that I can cancel out. I notice that these have the opposite signs. I have a positive and a negative, so I want to change this 3y to a -6y. So to do that, I'm going to multiply this entire equation by 2, and when I do that, I get 3x plus 6y equals 6. Bringing down my original equation, my second one would be 4x minus 6y equals 8. Add those two together, I get 7x equals 14, x equals 2. Then I'm going to plug my x back into the original equation, so I have 3 times 2 plus 6y equals 6. I would get 6 plus 6y equals 6. Subtract 6 from both sides, I get 6y equals 0, so y equals 0. So for my solution on this one, it's 2, 0. And then the last one, I'm going to also use substitution, like I did in number 3. So I'm going to substitute my 5y minus 1 in for x. And when I do that, I get 7y minus 1 equals 13. 7y equals 14. Divide by 7 to both sides, and I get y equals 2. Then I'm going to take this y, and I'm going to plug it back into my first equation here to solve for x. X equals 5 times 2 minus 1. X equals 10 minus 1, which is 9. So my solution is 9, 2. Alright, moving on to this graphing one down here. we're going to use this graph to solve this problem. Derek is going to have a party catered. Good Eats Catering Company charges $120 plus $10 per person. Food Fair Catering Company charges $150 plus $8 per person. Write a system of equations and use the coordinate grid to graph and find a solution. So for this one, I'm going to start by coming up with my equation. So for my first equation, Good Eats charges $120 plus $10 per person. So I have $10 per person plus a $120 fee. My second company, Food Fair, charges $8 per person plus a $150 fee. These are my two equations that I want to find a solution to. They want you to use the graph, so I'm going to go ahead and put my numbers in here. So 1, 2, 3, 4, 5, 7, 8, 9, 10, and then 15. And then these are my people, the number of them. And then on my y-axis, I'm going to put the money, or the cost. Alright, and for these axes, I'm going to go by 20s, so I'm just going to skip a few just to save on space here, but I'm going to go by 20. So 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, 260, 280, 300. Okay. So my first equation, my intercept is at 120. So I'm going to go to 120. My slope is 10x, so I'm going to go up 10 over 1, up 10 over 1, up 10 over 1, and so on. Just to kind of save on time here, if you graphed all of these, it would end up with a straight line going all the way about here. Okay, so you would have, let me redraw this. You'd have a straight line like that. Okay. And then for my second one, my intercept is at 150, so I'm going to be in between my 140 and my 160 here. For this one, my slope is 8, so I'm going to go ahead and change that to 80 over 10, because 8 is the same as 80 over 10, just so it's easier to graph. I'm going to go up 10, 20, 30, 40, 50, 60, 70, 80, and go over 10. And then I'll do 40 and 40 over 5, since that is also equal to 8, just so I can get up a little bit more here. So 10, 20, 30, 40 over 5. So you'll notice right here, they intersect at 15, 270. So they will be the same price when there's 15 people, and it's going to charge $270. Okay, and that's the first side of this, your study guide, and I will do the next side in another video.